Geometry Common Core, Regents Review, Video 9. The regular polygon below is rotated about its center. Which angle of rotation will carry the figure onto itself? Well, if you picture this, inscribed in a circle, better than I drew it there, what you can see is the 360 degrees of the circle is cut into 1, 2, 3, 4, 5 equal sections. And you could also think, it's 360 divided by how many angles it has or how many sides it has. And this is a pentagon with 5 sides. And 360 divided by 5 is 72. Now, 72 is not one of our choices. But 72 degrees would be if we, started here, it would rotate onto this point. What if I wanted to rotate onto that point? Well, that's 2 72s. So if we plus 72 to that, we get 144. If we add another 72, we get to that third spot, 216. And yet another 72 would be 288, and then the last one would be 360. We see that 216 is one of our options. The greenhouse pictured below can be modeled as a rectangular prism with a half cylinder. So we have rectangular prism, half cylinder. And the prism is 20 feet wide. We see that here, and so it's 20 feet wide, 45 feet long, so the area of that base is 20 times 45, and has a height of 12. And the cylinder has a diameter of 20. Anytime you see the word diameter, automatically write R equals and cut that diameter in half. So we have a radius of 10 feet. And it's all in the same unit. And then what is the volume of this greenhouse? So it's a composite volume shape, and so we're going to need to do the volume of the prism, which is the area of its base, 20 times 45, times its height, and most people tend to think of that as just length times width times height, same thing. And the volume of the half cylinder is pi r squared, remember the radius is 10, times the height. Now the height of this cylinder, the circular part of the cylinder is the base, and so this is actually the height of the cylinder. It's kind of like the length of its cylinder. This is almost like a cylinder on its side, but the height is going to be 45 here, and then we're going to have to divide this by 2 because it's not a full cylinder, it's a half a cylinder. Our calculator will do all this work for us, and I already have it pre-typed in here, that if we do the length times width times height, we get 10,800 pi r squared h divided by 2 gets you the volume of the half cylinder, and the two volumes added together is the volume of the entire shape, 17,868. All right, now the third question in this video is really kind of the big one here. It is a statement and reason part 4 proof. And the part 4 proofs here tend to be long, like we're probably looking at maybe, 8 or 10 steps. And they almost always involve parallelogram properties, whether it's a parallelogram, a rectangle, a rhombus, a square. So you really need to know the properties of those shapes, but also how to prove them. And so let's take a look first off at what they give. Now, just looking at this shape right here, to me it looks like a parallelogram. They don't tell us it's a parallelogram, but I'm kind of storing that in the back of my mind maybe for later. And what do they want? They want us to prove EF, this, is congruent to GH, this. Now, typically, pieces like that are proven congruent with CPCTC. Like, I'm going to prove triangles are congruent that have those pieces. And so the triangles, I think in this case, are pretty obvious which triangles we're working with. But let me draw them out a little bit for us. So I'm trying to prove this triangle is going to be congruent to this triangle here. And if I get that, then through CPCTC, I could get those segments congruent. There's a little piece of red there, get rid of. Okay. So, every teacher kind of teaches proofs differently. I like to, state a given and kind of use it for what I can and run when I'm ready. Then I'll move on to the next given. Some will have you say all of the givens all at once. Stick with whatever method you've been doing all year. And if it works for you, then that's great. If you want to do this the way that I do it, that's fine too. And if anything, you should probably pause the video, try this yourself on a piece of scrap paper, and then watch the video and see how you did. Really, you should be doing that with all these questions. So let's see. The first given is AE is congruent to CG. And so we state that as given. Now I do not number my statements as I go. I draw lines to keep them together. Again, you could just stick with whatever method you've been using all year. Now AE and CG, that is a side congruence right there. So that's one of the three congruency statements I need in order to prove the triangle's congruent. So that's great. And I don't really see anything else I'm going to do with that just yet, so I'll move on to the next given. The next given is BE is congruent to DG. Now that's out here. So that's not really helping us with the triangles, at least not at first glance. All right, so let's hold off on that for a second and see what else is given to us. Okay, so let's see. We have AH congruent to CF is given. And that's this little piece congruent to this little piece. And you notice that that's part of one of your sides of like this triangle, but it's not the whole thing. You're given something too short. And typically when you're given a segment too short, that's a sign that you're likely going to be doing the addition postulate. And what do I need to add to this segment to make it what it is? I need HF. And the reason why I can do that addition is because HF is what I'm adding to both of them. Now before you do an addition such as this, you have to state that the thing I'm adding to both of them, even when it's the same piece, is reflexive with our reflexive property. And then I could do the addition. And the way I always teach the addition is you add these pieces together and their sum equals these pieces added together. And the result of the addition is AF is congruent to CH. And what we're doing here is called the addition postulate. Okay. And you know, it always kind of works out that the things usually are on top of each other. So it's this plus this equals this plus this. But really you can see it, you know, on the image here that I'm adding these two together to get the whole side. I'm adding these together to get that whole side. And when you're adding, you always end up dropping the common letter. So I drop the common H. I drop the common F. So that's the addition postulate, and that's another side congruence. And then you're given that AD is congruent to CB. So AD is congruent to CB. And those aren't even close to attached to the triangles that we're working with here. So what could possibly be the reason for that? Well, now we start to remember, wait a minute, this looks like a parallelogram. And almost all these part 4 proofs involve parallelogram properties or rhombus properties, that kind of things. And there's 4 ways to prove a parallelogram. We could have diagonals bisect each other. That's not relevant here. You could have 2 pairs of opposite parallel sides. I'm not giving anything parallel. I could have 2 pairs of opposite congruent sides. And wait a minute, I know these pair of opposite sides are congruent. Do I know this whole thing is congruent to this whole thing? Well, the fact that I was given that and this little piece means I can add these together to get the whole thing. And that was why they gave us this congruent and this congruent, is they're trying to get us to prove this is a parallelogram. And once I know it's a parallelogram, then I could start getting into the parallelogram properties. But anyways, the one other way of proving a parallelogram is 1 pair of opposite sides congruent and parallel. So you don't always have to work with 2 pairs. So I'm going to go back, and it was really these 2 things right here. I'm now going to do the addition with those 2 to get that whole side. And so let me draw that line and do the addition there. So AE plus BE equals CG plus DG. And that results in AB congruent to CD addition postulate. And now what we can do is, because now we were given that complete side, now we have this complete side, that complete side, we could say this is ABCD. We could say parallelogram ABCD because it is a quadrilateral with two pairs of opposite congruent sides. And if I'm going too fast for you, please pause the video at any time, catch up, think about what's happening here. All right, so now that I know this is a parallelogram, now I have two side congruencies already. I have this side and this side. Parallelogram's not going to get me this other side, but parallelograms not only have opposite sides congruent, but they have opposite sides parallel. And with these parallel sides, I get that Z pattern, which will lead to alternate interior angles. So I'm going to say angle 1 is congruent to angle 2. But alternate interior requires you to say the parallel first. So I'm going to say AB is parallel to DC. AB is parallel to DC because the opposite sides of a parallelogram are, I almost wrote congruent there. Actually, let me do this all in one row to save some space. Are parallel. And then I could say angle 1 is congruent to angle 2 because alternate interior angles of parallel lines are congruent. You should really say that whole thing. Some people just want to say alternate interior angles are congruent. You want the of parallel lines because that's really why they exist. And so that gets me that third congruence I needed to prove these triangles. So what are the triangles? AEF. So I'm going to say triangle AEF, and make sure you list them in corresponding order. So what corresponds to A is C, and then G and H. So CGH. It's congruent to triangle CGH. And if I look at my image here, that's a side, two sides, the angle between. Yep, that is definitely side, angle, side. And now that the triangles are congruent, we can say the last thing we've been waiting for, what they want us to prove, that EF and GH is congruent to GH because of CPCTC. They are corresponding parts of congruent triangles, which makes them congruent. So that's it. It's a long, drawn out, a lot going on there, a lot you have to kind of see what they were getting at, so these questions are difficult. You do your best, try to find two triangles, make them congruent, if anything, try to work through it. And a lot of times there is more than one way to do it, but they are a challenge. So keep your head down, keep working hard, and do your best if you find yourself with a long Part 4 statement, reason, proof. That's it for this video. Good luck.